tēnā koutou katoa. Welcome everybody back to day 2 of the ITSNZ conference. We're going to try and keep right to time today. We've got a very busy day, lots and lots of speakers. I think we'll probably have a few people who had a great time last night sneak in as the morning goes on. We're going to start off this morning. My name is Liz Yeaman, by the way. I'm your MC for the conference. I'm an engineer. I actually work in an adjacent area of electric vehicle charging, so lots of intelligent stuff happening in that. As you can see, I was speaking a lot yesterday. So this morning's session is on data, AI, and predictive intelligence. And we will get going on that quite soon. First of all, just a couple of announcements. We are using the Slido app. Can we have the Slido QR code up, please, for asking questions? Unlike yesterday, we are not going to have a Q&A session at the end of each session. Instead, we will ask the questions if the time allows for the speakers. If you don't have time to get your questions asked, this is the point of a conference. People are around. You can meet them over morning and afternoon tea and have a chat and find out what you want. You will have been sent a survey by email. It will be from Donna in your inbox this morning. Please take the time to complete that survey. That would be great. And don't forget also to register for the ITS AP Forum, the Asia Pacific Forum that is happening here in New Zealand next year. It's a great opportunity to attend an international conference without having to travel very far. There is a QR code to get registered for that, which is available in that little Harry Potter hole under the stairs where Kim and her colleagues are sitting. So if you want to come along and get that, they have a special deal going at the moment, which is going to be the cheapest rate that you will ever be able to register for that conference at right now. So take that opportunity while you're here to do that. Now I'm going to get going and invite the first speaker up. The first speaker is Gavin Hill from Austroads. Please welcome Gavin Hill. Thank you.
All right, good morning, everyone. Now, I trust you can hear me okay. Plenty of seats down the front too, for those that are coming in. Thank you so much for allowing me to speak at your conference today. As someone from the other side of the ditch, it's a delight to be here and to be in Auckland. It really is a beautiful city. What I want to talk about today is really just some insights that I'd like to share from the other side of the ditch in terms of what's happening in Australia when it comes to data and road network management. But I want to start by just, for those who are less familiar with Austroads and TCA, just to give you a bit of a very brief summary. We've been around for 90 years, if you didn't know that, and one of our members is the New Zealand Transport Agency. So while we're called Austroads, it's a bit of a misnomer. And for those who are familiar with us, we do lots of research, collective research, and we produce guidelines and standards and advice for practitioners amongst our member agencies and for people working for member agencies. New Zealand is a really important member for us. They've been a member of Austroads for about 30 years now, and Brett Glidden, who's the head of NZTA, is also our deputy chair. So he has a really strong interest in what we're doing, and he's really keen to transfer knowledge and expertise and capability across the ditch. I'm going to talk about what Transport Certification Australia is doing. It's a legal subsidiary of Austroads, and it actually was born out of an Austroads project about 25 years ago. And what I'm going to talk about today are the business and technical and regulatory underpinnings which lead us to the use of data for road network management purposes and what we're doing in Australia. And I want to present this as possible food for thought around some of the reforms that you're progressing here in New Zealand. This slide I could talk about for 15 or 20 minutes alone, but time doesn't permit me to do that. If you want to grab a coffee afterwards, just let me know. I can talk about it in further detail. But what TCA does is really encapsulated in this image, and it's the managed interrelationships between the technology sector, which is the bottom left-hand quadrant, authorities at the top left, and transport operators or road users down the bottom right. We've talked a lot about interoperability in this forum and in this arena, the ITS arena over the years. And what TCA does isn't just around interoperability around technology. We're talking about interoperable business, regulatory, policy and business arrangements that enable things to occur in a seamless and standardised way. So if you go back to the nature of Austroads and why it's existed for 90 years, it's all about systemisation and consistency across Australian and New Zealand borders. In terms of what TCA is most well known for, we develop performance-based specifications for technology providers to meet. And I'll get to that a bit more in a moment. And we certify and audit those technology providers against those agreed technical, policy, legal and business requirements. We also type approve the actual hardware that goes into the vehicle. And fundamentally, we manage the interactions between authorities, providers and transport operators or road users. I'm just going to pause on this for a moment because it's really critical. We've talked yesterday about how some of the reforms around road use charging are taking place here in New Zealand. And I have to say, as an Australian, you are miles ahead of where we are, and we watch with interest and we wave you on. But when it comes to authorities at the top left, they pull the policy levers when it comes to the use of in-vehicle technology for some public purpose. It may be a regulatory requirement, it may be a safety outcome, it may be related to heavy vehicle management or road use charging. What's important is that the policy levers that those authorities pull through the framework incentivise technology providers to come into the framework. And I'll show you what that looks like in a moment. So authorities create demand for technology. That's the takeaway message. And providers respond to those market demands and they see commercial opportunities to enter the space and provide technology outcomes and solutions to the road users or operators in this slide. I'm going to leave it there for the moment. Just keep those things in mind as I go through the next few slides, because this framework has been recognised globally. It's an international standard. It actually has numerous applications which grow year on year that range from things like road use charging, dangerous goods, vehicle monitoring, even messaging to drivers. It's built on core principles and standardisation. Just want you to keep those sort of messages in your mind. I will also call out, because this was an Austroads project 25 years ago, NZTA was instrumental in helping shape this framework. So I just want to make that clear. We thank you for your country's contribution in taking this to the world. And I think as Australians and New Zealanders, we're often a little bit too modest amongst ourselves. We are innovators in this space. And it was only 2 weeks ago that I was presenting to the Europeans on this very framework, because they're trying to do the same thing in Europe for a whole range of use cases. And the question keeps coming back, how did you do it? One way in which it did happen, and I'll get to this slide just in a moment, I'll just make one more point. One of the things that we did well was we put the user at the centre of everything we did. So I'm picking up from a theme yesterday. We have to put users at the centre. And what we saw in the early 2000s was road users coming to Australian governments and saying, we're starting to use this kind of technology. Can we interact with government and policymakers in a different way? It was that simple. And in a way, that spawned a marketplace of providers, which you've got here. This marketplace continues to evolve and adapt with new technologies and with vehicle manufacturers coming on stream. In terms of the way they're categorised, I'll just make it simple. There are different levels of assurance and different kinds of ticks that we give to different providers based on the assurance that we provide over the top of those providers. So it's a combination of technical, legal and business requirements that we specify and the amount of scrutiny, independent scrutiny that we apply over the top of those providers. So it's worth pointing out, just in case anyone's missed the point, and I just want to point this out very quickly, TCA is not a technology provider. It's an administrator of providers. And this provides a marketplace, an open marketplace, where governments can point to when they're introducing a reform through legislation or regulation or whatever else. And rather than governments trying to procure services through the marketplace, through traditional means, we enable this on behalf of our members and other stakeholders. And TCA is part of the institutional fabric, therefore. The reform is the institutional arrangements that we've established, which enable us to be an important player in the ecosystem when it comes to generating and receiving assured data from vehicles. TCA, besides providing assurance around the use of technology, is also a data aggregator and a reporter of the data we receive that's consistently applied across all those technology providers. We can do that because we make sure that every technology provider talks the same language. It collects the same kind of data, and it's built on an underpinning of privacy by design. And one of the things that TCA was established for was not just to be a certifier, an auditor, but to be at arm's length from government and to be at arm's length from ways in which government agencies could access data. So that means TCA is like a safe harbour for data that's collected for a whole range of purposes from vehicles on the road network. That's important because when it comes to trust and confidence, and we heard this yesterday with the road use charging discussion, people need confidence and trust that there are safeguards and protections in place. TCA is like a castle with a big moat around it when it comes to data. And that has worked terrifically well in Australia, where we've got really strong privacy requirements and an inherent distrust of big government collecting lots of data. And what it means is that we have a digital platform which you can go and play with if you're registered, and it enables stakeholders and governments to see aggregated, anonymised representations of all the data that we collect across all types of vehicles across Australia. We did a proof of a use case with NZTA 18 months ago to see whether this would work in New Zealand with real New Zealand operators and road users, and yes, it did work. So we're starting to work with NZTA on moving this across the ditch so that the same benefits that we're deriving from road use data in Australia can be applied equally in New Zealand. So that's all the machinery behind what I'm about to present and wrap up with. Governments are using this kind of data in Australia for a whole range of purposes. When we're collecting continuous standardised data from a whole range of vehicles every second of the day, every day of the week, it gives us enormous insights into the movement of vehicles across the road network. This is an example of the kind of data you get from 6 months of data collection earlier this year. This is from January to the end of June. And these are just samples of what we can provide. But what's important is that the thicker the line, the heavier the road use. and we can start drilling down into all sorts of detail to better understand where vehicles are moving. What we found, for example, was that in Victoria, we had a national freight route, which was designated there in green. Yet most heavy vehicle movements were not taking that route. They were taking another route to the right. And there were all sorts of practical, operational reasons why that was happening. But it meant that we had a misalignment between road funding and road classification, which wasn't apparent to the Victorian Department. As a result of this kind of analysis, they're now directing federal money to that adjacent road, because what's important is that it's a less safe road. It's a road that wasn't designated appropriately, but through the data that we were able to capture, we were able to better understand what was actually happening on the road network, not based on assumptions. And one of the other things that TCA does when it comes to freight movements is we also recognise technologies that are used for weighing vehicles. And we're talking about technologies that can actually measure the mass of individual axles. And that's really important when you're looking at improving access and improving productivity of freight movements. And once you start collecting this kind of data, and once you start aggregating it, you can do all sorts of interesting things. So we have a bridge here in New South Wales near Newcastle. It's an old truss bridge. It's highly vulnerable. But what we've got down the bottom left are the total mass readings across a population of vehicles, which indicate a long tail of overloading, which for the bridge engineers amongst us gives us significant pause for concern. That's a compliance issue. It's an issue in terms of the bridge capacity, and it's an issue for what investments around maintenance and upgrades go into bridge maintenance. This is really critical stuff. I show this because when I hear about road use charging in New Zealand and its origins, it was based on heavy vehicle road use. What we've got now are technologies that can give us the kind of insights that our predecessors could only have dreamt about in the past. So if you know the location, the movement patterns, the mass, and the configuration of vehicles, well, I'm told, based on our engineering friends, that's the trifecta. That's everything you need to know to better understand how your road networks are being used. And because we standardise the data collection and we ensure that every point of data is the same across every provider and it meets the same integrity and reliability and accuracy requirements, then there is assurance built into these representations. So the days of counting vehicles by clipboard or using loops in the road or other old technologies at a single point location, those days are over. And for Australia, with a big land mass like we have, it's just not feasible to do that at scale. We're moving the traffic counters into the vehicles. That's what we're doing here. And that's a tremendous opportunity that enables Australians to better move freight and better understand where vehicles are moving across the network. Now, while I'm talking about heavy vehicles, this framework wasn't built for heavy vehicles. It was just that policymakers in Australia saw the biggest opportunities over the last 20 years to do more with the infrastructure we have and to squeeze more out of every kilometre of asset that we have. And we talked about that yesterday around the use of ITS. I'm going to leave it there, but can I just make one point? Australians actually did a report on battery electric heavy vehicles. This is our new challenge, not just in Australia, not just in New Zealand, but across the globe. Heavy vehicles and vehicles generally are getting heavier. There aren't any easy solutions to this, but ITS and in-vehicle technologies provide a way to manage this new challenge. I won't go through the flow chart here. Go to the report for more information, but it's a global challenge, and I think as Australians and New Zealanders, we have the opportunity to do so much more with the challenges that lay ahead through in-vehicle technology. So I'm going to leave it there, but I'm going to just pose those questions on the slide. I won't speak to them, Liz. Thank you for the opportunity to speak. And one thing we do need to sort out is if we're going to represent New Zealand appropriately in this space, we probably need to look at our names, don't we? Probably Austrades and TCA needs to have a stronger New Zealand focus. If you've got ideas about what you might like us to be called, grab us over a coffee. Thanks.
Thank you. Thank you very much. I'm definitely going to be downloading that Austrades report. I've seen some road trains start to be electrified now with batteries driving each part of the road train as well. That's really interesting stuff coming through. Not time for questions, but catch up at the break. I'd really like to welcome to the stage now Duncan Murcott from AccuSensus. I'll hand over to Duncan. Thank you.
Great, thank you, Liz. Just checking, is this working okay? We're working with a microphone this time. That's great. My name is Duncan Murcott. I'm from Australia. I was born up in a road safety family. I spent my years from 13 till about 21 running around defensive driver training in Australia and New Zealand, working with improving the road safety of our two countries. So I'm really excited to be here today, thanks to ITS and thanks to the University of Auckland for putting this on. It's a really great opportunity for all of us to come together and have a bit of a natter and a bit of a chat about the things which are important. Today I'm here to represent AccuSensus. AccuSensus was founded with a very simple belief that nobody should die on our roads. The presentation today is about how we can create behavioural change across our road network, change which is sustainable and change which the public accepts. And I'm going to talk to you about the evidence that we've seen from doing this in Australia, in Europe, and in the US. And I'm going to ask three questions, or one key question that I'd like to leave you with to ponder about as we go through this presentation. And that is, if we understand there's a problem out there that has to be solved which can save lives, if there's technology which can address it and is proven to address it, then why aren't we using that technology more often? This is the very first, or one of the very first images which we captured at AccuSensus. It was in 2018. This is clearly an offence. It's clearly unsafe driving behaviour. And this was one of the very first images we caught in our proof of concept in New South Wales. This is an offence. This is a bad behaviour which could not be caught from a police person by the side of the road monitoring what people were doing in their cars. This is a photograph that was taken from the AccuSensus technology, which tracks cars as they come through, takes the photograph, discards images if there's no violation occurring, but then if there is a violation, sending it forward to the police in the same way that a speeding violation is sent to the police. We are now doing this in more than 25 locations or 25 contracts around the world, capturing more than 1 billion images a year and using those billion images to change the behaviour and to remind drivers that, hey, this sort of behaviour is not acceptable. We also have programs here in New Zealand. We work very closely with the NZTA around the safety camera program, or speed cameras in layperson's terms, operating across all 16 regions, run by Tracy, who's sitting here in the middle. Put your hand up, Tracy, and her team, doing a really fantastic job in cooperation with NZTA. But this particular discussion today is not about that program. We'd love to talk to you about that program, but today's not it. Today is all about the legacy of a young man called James Rapley. James was an ITS engineer. He received a job offer to move from Melbourne to Los Angeles. and on the weekend was cycling and was killed by a distracted driver. One of James's best friends was a gentleman called Alex Janink. Alex is the founder of AccuSensus. He was motivated and inspired by the death of his close friend to start up AccuSensus because he believes, as we believe at AccuSensus, that this sort of crash, this sort of incident should not occur on our roads. At the time, there was no technology which existed, so Alex quit his job and started up AccuSensus to identify drivers that were doing these sorts of really bad behaviours. That particular incident has motivated all of us at AccuSensus and reminds us that these are not numbers that we're talking about when we're talking about crash statistics and fatality statistics. What these are lives being impacted. And these are lives being impacted way too often across our roads in Australia and in New Zealand. These are some of the examples of the photographs that we've taken. These are not trial photographs. These are photographs taken off the roads, in this case in Western Australia. Clearly this person is taking his driving just a little bit too easy. This person must have a wonderful novel they're reading because they just can't put it down. This person's gone to a lot of effort to make sure that the bell and the chimes aren't ringing to make sure he doesn't have his seatbelt connected. I mean, really, the energy and effort it would take to do that. And we can have a laugh about some of these things as we do, but there's some things which we can't laugh about. And that is the prevalence that we've seen from the images that we capture of people not buckling their kids in. And as we all know, this doesn't take much for a heavy braking incident to occur, and you know what happens from that point forward. We could have shown you tens of these images, which are shared by WA. AccuSensus does not have access to these images. From a privacy point of view, these are all with the enforcement authorities. They've given us permission to use these images. You've got an issue in New Zealand as well around road trauma. That's costing you approximately 270, 300 lives per year, and we understand this year that road trauma is increasing. There's more that you can do. And a reasonable percentage of the incidents and that road trauma are caused by people being distracted while they're driving and not wearing seatbelts. I know you mentioned yesterday, and it was mentioned a few times, the cost of traffic congestion around Auckland. In my view, that pales in significance to the annual cost of road trauma across New Zealand. And it's our belief that the technology exists and we think you can do more. We'd love you to do more, and so would some of our team members like Anju. So at AccuSensus, between 7 and 10%, depends on the month, of our team are people who have been directly involved in road trauma, and we've set up our organisation and facilities to help some of these people who find it difficult to work to have a meaningful job. Anju's one of those people, and she comes into work every day knowing that she's doing what she can to stop incidents that have happened to her and her family happening again on the roads of New Zealand. And you may say that, well, it's not that much of a problem. We often hear this. We did a trial a couple of years ago with NZTA. We don't call out specific countries, but you can read between the lines. We've done 2 trials in Australasia, Oceania. One of them was Australia and one of them was New Zealand. New Zealand ranks about mid-pack as far as offences and the prevalence of distracted driving on the roads. And this is actual data from the systems where we can see what every car is doing. Thankfully, you're not as bad as Washington, DC, over there on the far left, and not as bad as Italy, which is Europe #1. But there is an opportunity to improve quite significantly and reduce that trauma on the roads in New Zealand. I think we all know the issues around why this is a difficult challenge to sort of understand whether people are on their phones while they're driving. You've got the glare issues, you've got the speed issues. You need to design a system which takes privacy into consideration in a significant way. But also we know we can't have thousands of policemen around the roads. It's not affordable and it's not acceptable. So through Alex, what he did is he developed a system. It answers all of these issues, and the net result of this is a very good system for understanding if people are breaking the law, if people are doing poor driver behaviour and causing risk to others while they're out there on the roads. This is what it looks like. The systems are portable, which is important in countries like Australia and New Zealand, where we've got a large rural road network. They also work with fixed systems on gantries, as you would well expect. And the interesting thing from what we've worked with is that system now doesn't do distraction of seatbelts, it does speed, it does average speed. We can monitor close following. We also spot unregistered vehicles or closed lane and allow the enforcement authorities to manage that. We now have, and we've got a validated trial from working with the Department of, with New South Wales, a red light system which is built into this as well, so the portable unit can sit in front of the red light and see if there's people rushing red lights or running red lights, and we can also track close following as well. I'm not sure if close following is a law here in New Zealand. Privacy is core, privacy is key in the evidence that we capture. There is no direct evidence of an individual in the photographs. There are multiple images taken. It's only when you connect those images together that you can connect the evidence with the number plate of the car to understand that actually there's an offence being registered here. All the photos of non-violations are deleted at the side of the road. So there's AI at the side of the road. Most of those images don't go past the trailer or past the camera unit. It's only when there's an offence that they get sent on, in the same way that a speed violation gets sent on to the enforcement authorities. Like I said, we've been doing this now for a couple of years, since 2018. This is not new technology. Gavin, we're also innovators. We're just a little bit younger than you with the innovation that we do. But this is solid technology. This is out there. It's been proven in a number of jurisdictions. In the US, we're in about 13 states. In the UK, we're in about 4 counties. In Australia, we're in most of the states. Just very quickly, I'll take you to the data of the impact it makes. This is in New South Wales. We started off with about 1 in 200 drivers being identified. Now it's about 1 in 1,200. You say that's interesting. Enforcement is, or the number of people and the behaviour change is one thing, but what about fatalities? Fatalities, when we implemented this program in New South Wales for the first 24 months, declined by 24%. Now, we're not trying to claim that there's causation here, but we were certainly part of solving the issue. However, what is interesting, and you look at the other states in Australia where the solution has been implemented, you've seen similar sorts of trends in the data, where in Queensland, South Australia and Western Australia, they've also had significant decline in the fatalities on the roads. The one major state which didn't use the system is a really good base case to compare against, where fatalities have gone up. One area we can say there is definite causation is when we look at seatbelts. You can tell if someone has been injured or killed in a seatbelt from not wearing a seatbelt. Queensland did a study on that very recently, and they've said that the systems over the last 2 years have directly saved about 29 lives. I'd reckon that's about you guys. And I'd say you all represent the families and the friends and the kids of those 29 people. This technology impacts people in a very significant way. It saves lives on the roads. Same thing in the UK, same thing in the US. In the US, in one stretch of road, we've reduced the number of fatalities to 0. Anyone who's connected to the Vision Zero program understands the significance of that. Because if all of our communities could implement this one and get their fatalities down to 0, that'd be a pretty damn good net result. So I'll finish very quickly with the technology exists. The problem is understood. Big question is, why aren't we doing something about it here in New Zealand?
Thank you. Time for one quick question from the Slido there. How will you monitor impaired drivers?
We have an impaired trial which is underway at the moment. We ran our first one in the UK 2 years ago. What this does is it works directly with the police locally. Those images are not sent for enforcement. The images are sent to the police down the road, and the police can then identify which drivers they should be pulling over to do a test, a drug test or a drink driving test. We're actively trialling it in the US right now.
Great. Thank you very much indeed. I'm delighted now to hand over to Andy Prow from Qubit Cyber. Thank you.
Yeah, good, thumbs up. Okay, so good morning. So I'm here as the cyber guy, and I need the clicker. So as the cyber guy, so I'm old enough now that I've had 10 years as a software dev for critical systems and 22 years trying to hack into and break into those same critical systems. So as the cyber guy, funnily enough, the very definition of the industry that I'm in is the protection of computers and networks. That is how we've defined cybersecurity. And so most of my career, when there is a breach, it's recorded in like data. How many records were breached? What type of data was it maybe? Was it private data? Was it healthcare? Was it my credit cards, my passwords? And so this is, or we record breaches in how much did it cost? How much money did I lose? And so the issue here is, as the cyber guy, my job is getting harder every single day. We have more code being generated, doing more meaningful stuff. An ITS couldn't be more relevant, right? But here's the issue. So here's the issue. So as the cyber guy. So let's just take a system, a piece of software. And so what's interesting, let's just say some of the stats are 14 billion IoT devices around the world at the moment. So IoT, as we all know, is basically just a computer, just does something. And out of that 14 billion, they reckon about 1 billion move. In other words, in the transport sector, aviation, mobility, road, air, rail, 1 billion of these devices move around. Now what's interesting is the cyber guy, you're like, Andy, can you make sure it's got no security flaws? And you're like, ooh, easy, Tiger. So Linux is still a very common operating system for IoT devices. Base Linux these days is 43 million lines of code. You're like, oh, crap. And so we'll compile that down to maybe less. But here's the issue. That system, it's not just the code that the user's writing, but I've got device drivers, and then I've got all the other firmware that goes with it. And that keeps getting updated. So here's a question. Who here has heard of an SBOM? Hopefully someone. Yes, good. So SBOM, software bill of materials. I'll often do this kind of presentation where we've got a can of baked beans, and I will challenge that the can of baked beans has more information on what's inside it than your multi-million-dollar piece of software. So one of the first things I'm going to say for anyone doing any transport systems is you should be asking for SBOMs and providing SBOMs, a software bill of material. So the first thing that happens is the cyber guy, you're like, right, you've got this system, Andy. There's a new security flaw that's just been discovered. And am I vulnerable? And you're like, hang on, let me have a look at all the gubbins that goes into your system. Let me see if you've got that library that is vulnerable. So this is actually quite a hard job. Out of millions of lines of code, then if only I had a software bill of materials that would describe what was in the one system. But the job isn't about one system anymore. Everything we look at is a system of systems. Well, that job I just said of millions of lines of code, which, by the way, often the user code that we write as the devs, it's often only 1%. 1% of stuff is new. 99% is all the other gubbins of third-party code that went in there. System of systems. The same problem at mass. All of these systems now talk to each other. All of them have different versions of software. They've got different protocols. This starts to get really hard, and they're like, Andy, is this secure? You're like, hang on a moment, give me a while. I need to do some more testing. So, but then what happens is, what if this system of systems is now on a big moving vehicle? This is what any piece of modern vehicle tech looks like. It is a system of systems, that every component has got quite a complex software stack. In the engine management, the emergency braking system, the smart TV screens on the back of the seats, to the payment system, to the smart gantry, to the smart cameras that are at the side of the road. All of these things are either directly internet connected, talking to each other. And so the issue is, and then you're coming back to the cyber guy to go, oh, by the way, is this thing good? So I'll give an example of the modern shifting sands we've got. So as an example, one of our customers in the US, so AI developed code. So they don't stop, 7 days a week, and they do 2 releases a day, okay? 14 releases of software a week. Cool. And they said, can you test the system? I said, yeah, it's going to take about a month. And they're like, well, that's 28 days. That's 56 versions late. By the time we finish testing, there's 56 new versions of the system moving forwards. And you're like, huh, that sucks. So what I'm saying is the cyber guy, we keep getting asked, oh, is that bus safe to go on the road? I'm like, so the cyber job is actually getting quite hard. So then what happens if we have a system of systems? And now I've got a smart moving city where every single one of these vehicles is from a different provider running different versions of the software. So again, you guys and girls all know what intelligent transport systems look like. So imagine now my fleet's been out there for like a year, 2 years, 3 years, 5 years, 15 years. Is every single one of my buses running exactly the same software stack? And you're like, oh, crikey, no. I've got this one's 4 years old, that one's 5 years old, I've got different versions of everything. And so the moving target of, by the way, what's the cybersecurity posture of my city right now? Like, is it good? So I'm going to tell you as the cyber guy, literally an impossible question. Impossible. I cannot tell you that every single moving vehicle right now is fully patched against all of the latest security flaws. So the cyber guy is saying, I can never tell you if this thing is secure. Well, that sucks. Just saying. So the question we're being then asked, and I think a more intelligent question, is not, is this thing vulnerable? Because I'm going to say yes. What I actually want to know is, how does it behave when breached? That's actually a far better question. This is basically engineering and safety, failure mode and effects analysis. I can't guarantee it'll never fail, so now tell me what happens when it does. And yet in cyber, we keep being asked, is it perfect? Has it got any vulnerabilities? Did you pass that penetration test? Yes. Did it pass the audit? Yes. How long ago? Last September. That'll do. I'm like, no, it won't. But this is what we're asked in cybersecurity. Does it have any security flaws? It didn't 9 months ago, or at least based on the 1 month you gave me to test it, it didn't have any flaws 9 months ago. Like, really? So where things start to get interesting is then indeed rolling AI on top of all of this. So modern stats from Google in the last 18 months, they've gone from 25% to 50% to 75% AI-generated code. Okay. GitHub, one of the world's largest software repositories, 40% of code is now being checked in that is AI-generated. Cool. And so again, for one of our largest US customers, this means tens of thousands of lines of code a day are going into the system. But the system's so complex that AI is writing the code, but now the AI is deploying the environment because the environment's so complex. And then the system is running AI. So I've got AI-generated code on an AI-configured environment with an AI agentic sort of, weaponized or managed system. Okay. And it's not just that. So you've got AI generating the code. We've got AI starting to run the systems. We've got AI on the devices. It's very hard these days to find a modern device that doesn't have some AI somewhere. Now, I love AI. I use it massively because then as the cyber guy saying, by the way, I do 2 releases a day on something that's got tens of thousands of lines of code change, that's not a human problem anymore. So now we have AIs that do the security checking of the code that's being developed. So we're now getting to the classic be watcher watcher, right? Dr. Zeus got it right. So our AI is checking your AI to make sure it doesn't go wrong, and then maybe I need another AI to check that mine didn't miss something. So this is the world we're getting into. AI generates code, AIs are looking at the issues with code. But here's an interesting one. So those that have been in project management, you might have heard of RACI. It's who's responsible for doing it, who's accountable for it being done, who do we need to consult, who do we need to inform. So what's interesting here is AI is starting to get responsible for a lot of stuff. It's responsible for writing the code. It's responsible for deploying it. Maybe it's responsible for making a decision what it sees. But we haven't yet got AI to be accountable for what it does. That's still a human role. So the accountability. AI got it wrong. I need to put it in the corner on a naughty chair. Am I going to sue the AI? Well, I can guarantee all the frontier models, there's no point going to Anthropic or to OpenAI or Microsoft with a legal case about how the AI got it wrong. It wrote some bad code. No. So the AIs they're responsible for the workload, but they're not accountable for what happens. That's still a human thing. So if someone actually dies, gets hurt, is killed, well, the AI is not going to get sued. It's not going to go to prison for reckless endangerment of the public. Yeah? So accountability is a very human nature. And so what's interesting, when we have a lot of this conversation about who's accountable for failure, who's actually legally liable, Boards are legally liable for health and safety. So if the AI causes a health and safety issue, well, the board is legally liable for the safety of the public and your staff and your customers. And so what's interesting is we're actually having this quite large divide now with what the AI is becoming responsible for and which humans are actually accountable for it getting wrong. And I would say this is a major governance problem, by the way, which is if I'm on a board and if I can get in trouble for an AI screwing up, I really want to know how it can screw up and when and why. How would I know? How could I stop it? And how could I respond to it? And so what I'm going to say is, as well as, remember S-bombs, create S-bombs, ask for S-bombs, but also what I'm going to say is, if your security program looks something like a point in time, we will test something and see how bad it was, and then move on, I'm suggesting we're moving into a doomed area. So I use the word continuous assurance. You're going to hear this a lot coming out of the cybersecurity, continuous assurance. If you have any lag time since you last did something, that's a problem, because not only does code change rapidly, but there's a phrase that we're using in cybersecurity. It's called the vulnpocalypse. It's the vulnerability apocalypse. And it's because things like, so if you've heard of Mythos or Glasswing, so what it is, so from Anthropic, they've got Claude. Mythos is one of their large models that we've trained on all the software languages. And it's actually quite good at coming up with security flaws. Security flaws we've never managed to comprehend as humans. The AI is now going, if I did that and that and that at the same time, I can compromise a system. You're like, yep. And so what we're saying is that in the cybersecurity land, vulnpocalypse is this new bow wave of vulnerabilities that we've never seen before on systems. So some of the systems, there was a big one in Microsoft, it's a 20-year-old system, poof, found a vulnerability in it that we haven't seen for 20 years. And you're like, And so this is what's coming through, new vulnerabilities, but then also the bad guys are using AI to weaponize what they do. And so we're now finding bad hackers are getting better. So the little red and green lines, it's not now how quickly do we need to look for the bad stuff, but I argue how much can we prove that it doesn't matter if this thing's hacked, it works anyway. And so this is where, for me, for our industry, cybersecurity is moving from cybersecurity to digital safety to digital trust. So the concept is, I've spent a career trying to find all the security flaws and stuff. But if this is now a set of traffic lights, or if it's an engine management system or a braking system, if it's a drone flying through the sky, then actually I'm not worried about the security of the computers and the networks and the data anymore. What I'm actually worried about is the safety of humans in a modern tech world. So there's a phrase that there's nothing worse than getting to the top of the ladder and realizing it's on the wrong wall. So I've spent a career trying to make sure nothing breaks into the systems. What we actually want to be looking at for the future of the transport system is tell me the people are safe when this is hacked anyway. Because I'm telling you, you can never guarantee it won't get hacked. It's too fast, it's too complex, too much of a shifting sands environment until the AI writes all the code for us or drives all the vehicles, future problem. But for now, this is what we want to be looking at. And so digital trust, if I'm an everyday human, I am an everyday human, but if I'm you know what I mean. But if I'm a member of the public getting on a bus, don't tell me when this bus last passed a pen test. It's like, Andy, it's got no vulnerabilities. But every time we find a vulnerability, the bus goes out of control and you will die. It's like, really? But it's got none today. It's got a clean tech from last week. I'm like, okay. What I actually want to get into is a bus that's like, Andy, this one's got 100 security flaws. I'm like, really? Yeah. But every time we hack it, the bus just slows down and stops gracefully. I'm like, all right, this one seems safer versus the one with no security flaws that will kill me if it gets hacked, based on the security guy saying, and I can't guarantee it won't get hacked. So this to me is the message to take away, right? Is if your security program is to make sure there's no flaws, that's half the job. Your security program should be, show me this system operates safely when it's hacked. That's where we should be heading. I tell you right now, that's not where we are. Not really time for questions on Slido, but this is it. This is where I spent my career. What we're after is digital safety and digital trust. If we keep getting this wrong, why would the public trust our systems if we can't guarantee their safety? Because I can't guarantee it won't get hacked.
Thank you.
Thank you very much.
That's going to leave everybody thinking. Thank you very much for that. Really, really insightful presentation there. I'm now delighted to welcome Matt Ensor from Kiora AI to the stage. Welcome, Matt.
Thank you. leaving the clicker. I've actually written some code, Andy, so you can probably hack into it by about in half an hour's time. We'll see. Thanks, everyone. Thank you for the invitation to come today. I've been coming to T-Tech since before COVID. It was very different back then. It's great to see how things have matured. I sort of live in two worlds. So I live in the AI world, which is changing every moment, it seems. And if you keep in that world, you kind of think we're all going to be out of a job by the end of the year, or robots are going to take over and all that kind of stuff. Yeah, don't stay in that world. Today we're going to stay in the real world. So everything I'm going to show you today, you can do right now. I do have one little robot video, but actually robots are probably next year or the year after. So we're just going to talk about stuff today. This is me on a good day. I come from civil engineering, where you get something wrong, it really does matter. At best you get sued, at worst someone gets seriously harmed. So I'm in this interesting position where I'm bringing generative AI into organisations, generative AI being a particularly inherently inaccurate tool, into organisations where accuracy is absolutely important. So my day job, I just work with organisations really to get them going on transformation through generative AI. If you were here yesterday for Shamabill's talk, he talked about the unicorn. Remember that? Here we go. This is my PowerPoint skills. So he said it's the unicorn. I just say it doesn't exist. You can't improve all three things at once, except of course now you can. So this is the big transformation, and over the next couple of years, every sector is going to move to a new standard: higher quality, lower cost, and higher speed. So I've got about 27 minutes to explain why that isn't a myth. AI's been around for a while. He's a nice little robot. If you want your gallbladder out, probably this will be a good choice. That robot's been trained by just watching videos of surgeons removing gallbladders, thousands of them. And apparently it's really good. Knows what to do, doesn't make mistakes. Great. The problem is if you ask that robot and you say, well, that's great, that's really good, thanks for the gallbladder thing, but where should I visit in France when I'm there next year? It will go, well, that's insane. I'm just trained on how to do operations. So this AI is quite easy to manage. This AI is not. So we've moved from predictable AI to very unpredictable AI. So this is generative AI. Generative AI is still trained on lots of data, but if you ask it a question that is not in its training set, something that's never happened, never could happen, it'll confidently give you the answer. So it's very good at making stuff up. Funny enough, we have a problem with the English language. The one thing generative AI is not good at is generating. Like, you have to leave now. This is great because I've finally got you to the point. Yeah, it's not good at generating. If you don't believe me, get it right now to tell me a joke about ITS. The joke will be rubbish. And then say, well, that's good. Can you review why this joke may not be funny in any context, any culture, any country in the world? And it will do a postdoc PhD for you on humour. And so this is all to do with the way the statistics work within generative AI. It is really good at review and analysis, and it's really bad at generating. And so one of the big things we see changing is people finally realising this and turning every task they have into a review and analysis task. It's also really good at, you can say, look, I really want this. Don't give me anything until you have this. And the AI is able to work out, well, how do I get to that point? Even if you don't know how to do it, it'll work out how to do it. There is one exception. I should go back, shouldn't I? It is good at generating code. The only thing it's really good at generating is code. And that's because code is kind of rational, logical, no exceptions, and all that kind of stuff. And so my very last example today, I just want to show you where it's got to with coding. Anyway, you're probably wondering why the spider's there. I was out and about, opened the door, this big spider came in. I happened to be in a hotel at the time. You will hear the receptionist at the front desk. I did cut off the last few words of what she said, so see if you can guess what she said.
Oh my God! Yeah, that's huge! That's the biggest spider ever.
Oh, well, that's curious. She said, oh my gosh, that's the biggest spider I have ever seen. Yeah, most people have words pop into their head, ever seen. Yeah, so you're just like AI, a plausibility machine. So what it does is it simply works out what's the most plausible next word. There's a bit of magic in there somehow, but that's pretty much what it does. The problem is, if she had said, oh, the sun is square because, it wouldn't go, well, that's not right. No, it would think about the most plausible way to explain why the sun is square. It doesn't know what's right and what's wrong. It just adds plausibility to whatever you do, which is a bit of a problem. Agentic AI. So imagine we ask it, oh, I don't know, something about ruck. That'd be fun, wouldn't it? It's got the whole world to choose from. Apparently LinkedIn and Reddit's very popular. You don't have to go to MCert anymore. Just ask AI. It'll take you to the most up-to-date views on the internet. No, you don't want that. And so what you need to do with agentic AI is say, oh, don't use anything from social media. You need to do it this way. Only use these documents, in fact, and never do this. Oh, and here's a template that you must put your answer to. So we call this coercion. And you must never use AI like this. Always coerce it, because what you do is you start to get repeatable, accurate, consistent results out of your AI. And I'll show you how to do that in a minute. The most dull slide, but the most common question I get asked is, oh, what platform should I use? And it's a good question. Because there are quite a few to choose from. Very briefly, the ones on the left-hand side, they spend billions of dollars a month trying to get things right. They're all American, apart from the last one, European, but they're driven by cash, by money, and so they are inherently private and secure. A lot of myths around, I'll put up my proposal, put in my medical information, and somehow, someone else will be able to download it. No, the moment those systems are not trustworthy, corporates will flee. So great. The only thing I'd say, and I tried this myself, a little startup called Frankly, don't try and compete with those five. Don't try and, and so Microsoft and Apple are both like, oh, we don't want to compete, we're just going to use those models. So Microsoft, we're using ChatGPT, now they're using Claude as well. They're about to start using DeepSeek, which is a Chinese open source model. Apple used to use OpenAI, now they're using Gemini. Can you see sort of a trend here? No one likes OpenAI, it seems. But you have that privacy and security built in. I don't have time to go over what the weaknesses are, but your password, big weakness. And you going, oh, I don't like Works AI, maybe I'll do it on my phone, big weakness. So we talk a lot about making sure that everything that's done in an organisation sits within enterprise versions of these things. I don't know if you're an AI cynic. If you are, this is the slide for you. These are the things that are baked in to the design of large language models. These are the errors that it makes that you just cannot get rid of. I'm only going to cover two of them. The most important, hallucination and sycophancy. Here's a nice, remember that robot at the beginning? So you're in for your gallbladder, they're like, oh, the machine learning robot's broken, but we have a ChatGPT surgeon who can do it. Run a mile. You cannot get rid of hallucinations. They're down 99.7% from a year ago, but they will still happen. Every 10,000 patients the ChatGPT surgeon gets, it'll go, oh, maybe I'll try something different. Yeah. The problem is humans were not great either. This is a real story, kind of sad. He took out the guy's liver instead of his spleen, died. My daughter, she's 16, lovely, got her license, so she's trained and licensed, certified. 3 days in, bang, crash into another car. I'm like, why'd you do that? She's like, I was in a hurry. Yeah, next day, back at the wheel. Yeah, if it had been an autonomous vehicle, yeah, probably a Royal Commission, something like that. Yeah, so we do have to weigh up, are we happier for humans to make mistakes or the machines? I used to think Boris was a bit until I saw this. And what it does is it proves that Boris is quite smart, because he understands that models are entirely sycophantic. So when you get into Copilot, ChatGPT, whatever, when you type in something, it doesn't go, oh, I wonder what the objective truth is. No, it says, I wonder what Liz wants the answer to be. If you don't believe me, I can show you. They all do this. They're psychoanalyzing you. It used to be you have to know what to ask. Doesn't matter anymore. It tries to work out what it is that you want. If you want proof of this, just ask one of the big four. I'm not picking on Deloitte because I could give you easily examples from these people. But no, Deloitte, famous case, they wrote a report to the Australian government. It made stuff up. You know why it made stuff up? Because they said, write me a report that gives the government what they want. If they'd... I'm glad you laugh. Yeah, these guys do it too. The government's like... the government was like, brilliant, we love this report. More. Anyway, it caused a bit of a kerfuffle because, you can cheat at school. Actually, apparently you can cheat at work too, if you do it like this. If Deloitte had said, write a report that critiques and rubbishes the government's point of view, they would have got that report. So you have to understand, sycophancy is the biggest risk. AI does not care about objective truth. It cares about making you happy. Right, what's it not good at? So, sorry to bring up my teenage daughter again, but this is very much her. Very confident in the things that she's wrong at. Do not use AI for things you don't know the answer for. We call them black box. That is not a task for generative AI. It's a bit like me, really, frankly. You go through and you search for stuff and you find what you want, you're like, brilliant, and then you stop searching. And AI has this problem. It'll search for the standards, it'll find one that's sadly out of date, but it doesn't care, it's found something that's really good, really important. That's one of the big weaknesses. I remember the spider. She said, that's the biggest spider I have ever seen. If the spider had been this big instead of this big, I doubt she would have said anything. She would have either stamped on it or run away. And we call that objective professional judgment. It's something that AI cannot do. AI is one word after the other. It'll be like, that is a very big spider, I should know. So we have this, you call it instinct. So if you've been 35 years in the transport advisory sector, you get a report, you're like, this doesn't seem very good. It's like, why? Oh, I don't know, it just doesn't seem very good. That is the thing that humans have that AI will never have in its current form. It cannot do that. And it doesn't know when it's wrong. So, here's a nice segue, a nice hold point. Who thinks that all our organisations should be run by teenagers who are like this? No one. So when you hear the tech, what do they call them? Tech bros saying, oh, everyone, all the white collar people will be able to work at the end of the year. No, they won't. Because you need this objective professional judgment. You need to know when you're wrong. This is an easy way of looking at it. To use generative AI, you need to have a human that tells the generative AI what is the problem you're actually solving. What's the nuance? What's the subtlety? Where should you find stuff? Where should you be coerced? And then you need a person at the end with objective professional judgment. We call it discernment, to work out whether the AI has done what it should do. Is it the right answer? Again, remember, if you don't know, then don't use generative AI. Well, that's all very nice. The biggest breakthrough, of course, is connecting it to your organisational data. So my surgical AI would be pretty lousy because I have no medical data. I've got no videos to show. But if you happen to be a surgeon and you connect your AI up to all the videos, for example, it'll do really well. And so we see this in organisations, particularly through Copilot Premium. They connect the AI up to everything that they know, all their SharePoints, and it does an amazing job compared to not connecting it. So people often go, oh, we've got Copilot Basic because we don't want to connect it. I'm like, don't do that. I kick myself because I'm old, so I call things automation. It is not automation, it is augmentation. Human, generative AI, human. There is no other option with generative AI. You can't do human generative AI, the world. No, augmentation. This here, what I suggest is you look at it brightly, like try and burn this image into your retina. This is the most important graph, I want to say in the world, but we'll bring it back. The most important graph in generative AI. This explains why 98% of organisations just don't know what they're doing. They get, oh, my emails are better. No. So on the left-hand, so basically the y-axis is proficiency at a task or quality or all the things that engineers and technical professions aspire to. So you can see on the left there, that's me or you by ourselves. Not so good, 0.05, whatever it is. I was taught in the 80s when I was pretty much in this room, get into a team. If you can't solve a problem as an engineer, get 20 engineers together and you'll probably solve it. So most of the world now works on that blue thing there. Unless you work for yourself, don't use the internet. No, blue. But here's the kicker. You can have the most powerful AI, and this is about a year old, this research, but they've redone it. You have the most powerful AI, and your level of proficiency will only go to the level of a human team. There's kind of a natural barrier there, and it's because you run out of discernment. I don't know if you've heard of a guy, Donald Trump. Donald Trump will not make better decisions no matter how good the AI is that you give him. Limited. What you need to do is move to the pink or salmon. So this is what we call transformation. So this is when you use AI as a team. So you share your prompts, you share your information. So instead of everyone tappity-tap on their own computers, you use the same agents, as we call them. So yeah, good on you for tappity-tap and doing a really good job with AI, but you're never going to get that kind of transformation. There's so much research out going, oh, people have implemented generative AI and got no benefits. Well, it's because they're doing the orange thing. Right, so I'm halfway through, which is good because the rest of the time I'm just going to show you some examples. So an agent is where, you know, the orange, like I'm really good, so someone down the back there, I'm not quite sure what to do. We're going to get different answers, different levels of quality. Imagine if we shared what we did. And so these are called agents. So what we do is we coerce it. We narrow it down and we connect it to organisational information. So this is real pink salmon stuff. Here's my review. I've got 5 examples. They're all in real time. I did them, you can probably see down the bottom there, the 6th or the 7th. Quite up to date. This is Copilot. I'm just going to create an agent for you. People go, how long does that take? As it turns out, about 3 minutes. My agent is going to review a business case. So what I'm doing, like I've got no particular skill here. I'm just typing in what I want the agent to do. Excuse my spelling. And what it's going to do is it's going to look at that, and then it's going to go and write its own instructions. AI knows AI the best. So I didn't realise I was typing quite this slow. It's late at night. Flag any gaps and inconsistencies. So I'm turning it into a review task. It's really good at review. And I'm saying, you can't make stuff up. You need to tell me the specific page and wording in the business case. So the only skill I have here really is understanding that the more coercion I give the AI, the better. Right, so that's it. That's it. Now I'm getting the benefit of the smartest AI in the world, who's working out what's the best way to do that. This is real time, so give it 10 seconds or so, and it will nail this. You drink a lot of coffee when you're in AI because everything takes about 30 seconds, and you're like, what do I do? This is what I don't smoke. Here we are, done. Right, so it's come up with the instructions. So you might type in, oh, review this business case for me, enter. No, you should be basically typing in pages and pages of instructions. Really, I should press the create button and it's done, like I'm happy. But just for the hell of it, I'm sort of showing you what's there. Right, I'm just going to show you how you can share it too, remember? Amber, rubbish, salmon, pink, good. So I could share this with my whole organisation, which would be funny because that would be me. But that's the idea, share it and then start to get people to improve it. Right, so go to the agent. This is probably the least exciting thing. I'm going to load up a business case and it's one with errors in it and we'll see what pops out. The point here, as I'm saying, is to move from amber to pink is not a big deal. You've just got to realise you can't do things by yourself. Done. Oh, am I adding in the... What is this? Oh, yes, I'm adding in the business case. Here we are. So I'm putting in all the traffic counts, the business case. So for you, you might have 50 files or something. Traffic counts, crash data. So what I'm going to do is it's just going to work out, has it made stuff up? And so what it will do, you'll see it'll write some little Python, little code there that Andy will be excited about to go through all of the crash data and all the traffic counts just to work out, have I done the right calculations? Writing some Python. Here we are. So, yep, it's all done. And so I'll skip on in the interest of time, but what you'll see is that the answer I'll get from there will be much better. And what I should do is share it with everyone, and over time, we'll update the instructions. We'll coerce it more and more and more. Suddenly, my organisation will start to grow. Risk is quite incredible. I said, create a detailed risk analysis spreadsheet for a typical ITS project. This is Fable. So sadly, you need to pay for this. I frantically did everything I could for free until July the 7th. So here is the risk matrix. So it's incredible at risk. Like since March, I don't know why it's so good, but it just blows me away. You're not supposed to be able to read that, but what you can see is it's gone through. It's given me a whole lot of risks from a typical ITS project. And this is the residual rating. So if I went to the left, these are with the mitigations. So you can see what the mitigations are that it's putting in. This is a generating task, so it's probably not so good. How'd you make it better? Turn it into a review task. My favorite, just type in, try harder, enter. And what it will do is it will review what it's done and it will be 10 times as good. You're like, why didn't you give me that the first time? Well, it's the way statistics work. Anyway, that's all very exciting. What I did is I put in, I added in the T-Tech26 program. I said, this is what people are talking about this year. Can you create me, oh no, I stuffed this up. Can you take me halfway through that video on that slide, please? Sorry, I thought it was a separate slide. I said to it, do me a risk matrix for all of the things that people are talking about, a little bit further on, at the conference today. Here we are, thank you. Just play from there. So what it's done is it's come up with, this is the residual risks that are left. The good thing is we don't have any extreme ones, but here we go. Here are the high residual risks. Public and political rejection of time of use charging, cyber attack on ITS platforms, a national shortage of ITS data, AI and cyber capability across agencies, consultancies, stop-start infrastructure and technology funding, political cycle reversals. Those are the ones where it says, I really can't mitigate these. Which is really bad news for us. But as you go down, it's because AI doesn't care about scale. I could put in the whole world's transport policy and it would give it a go. But have a look at what it's done. I don't know if anyone's here from MCERT, but hey, here are the key controls and mitigations. Now, the point is, I would argue, whoever's in NZTA at the moment, you probably know this stuff already. This isn't the great stuff, but what it's really good at is reviewing the matrix you might have already. Or it's really good at challenging and saying, oh, I hadn't thought about that. And as I say, just go try harder, then go try harder, then go try harder. After the fourth time, you'll probably get something quite amazing. Here's a walled garden. A walled garden, basically everything that happens in the garden stays in the garden. We also call them, in AI, we call them notebooks. And OneNote has been upgraded. You know, Microsoft OneNote, that terrible thing that everyone thought would be good. No, they've just upgraded it. It's incredible now. You might have wondered, why did Microsoft not tell me this? Well, it doesn't work. It's broken. And so they're trying to fix it at the moment, and that's why they haven't done a big launch. But what OneNote does now, or notebooks within AI, you put all your files in there, and the AI can only use those files. And it can't what we call editorialize. It can't make stuff up. Everything it does has to be just related to those files, which is quite amazing. Here's OneNote, which doesn't work, and you'll see me having to jump across to what did I jump across to? I think the Google product. So what I did is I just put in the T-Tech26 program, and then I put in the risk matrix for New Zealand. The only two things there. So I can create a mind map, an infographic, a presentation, a document, and it won't make stuff up. It'll just come from there. Now the frustrating thing is the infographic didn't work, so I went to another software and brought that out. But boy, oh boy, here's a mind map for T-Tech. Let's go to road pricing. That seems fairly, public acceptance maybe. What did I choose? No, charging models. There we are. And so what I can do is I can keep clicking down, and it will give me all the information from all the speakers and all the risks on that area there. It's not very pretty. It's not very beautiful yet, but quite an interesting task. Interesting tool. If you want to know, this is the infographic it created. I like the robot, which is going crazy. It's not quite, but it has an extreme score. Anyway, so you can guide it and say, well, that's great, but I really want an infographic on road user charging and those kind of things. So we've got to the point now where the ability to constrain and then produce information from knowledge is kind of with us. Just pay your $55 to Microsoft. This is probably, I think, the biggest change. So it used to be AI wasn't good at formatting. Drive you bonkers. Now it's perfect at formatting. This is I made up this, it's a project update sheet. And so what I've done, just put it into Word, and you see it's got lots of blanks there. I'm about to go and click the Copilot, so this is your $55 a month job. It is connected to my organisational information, and I do have one project in my OneDrive, which is New Zealand's worst civil construction project, which I got AI to make up, but I got it to fill it out with lots of data. So you can do this for any project in your company, as long as you paid your $55 and you're on SharePoint. Complete the template with an update for the Foxton Bridge widening project. And I do say this because some of the demos, it will, for some reason, it goes and hunts on the web, which is not very helpful. Off it goes. Details are on my OneDrive. So it's searching my whole OneDrive, and it's going to give me a project update on this. If you have, as it goes through, it doesn't take long. This is real time. It has to do a risk matrix, and there is no risk matrix in the Foxton Bridge project files. So it's actually, remember, it's brilliant at risk. Now, everything I do, I get AI to do me a risk matrix for, because it's like, wow, you never know. I said to my wife, actually, we should do a risk matrix on our marriage. She didn't laugh. I still think it's a good idea, but I'll maybe do it behind the scenes. So here we go. So it's filling this out. Remember, I was in Wellington, and they said, don't talk about the Immigration New Zealand project. I'm like, I have to. So MB, $30 million. Well, it wasn't them, but basically it was. They're accountable. Imagine if Chief Executive MB went in one morning and said, give me a project update on all the projects that don't look as though they're going very well. Enter. And as long as he had access to the whole of the SharePoint, it would have found the project and gone, this doesn't look very good. $55 a month. I'm pretty sure MB didn't want to pay that money. Now they will. But, I mean, this is a little bit, well, it's not facetious, this is real. But think about, it's not about making you more productive. It's not about saving $150 an hour through you going home at 3 o'clock. It's about saving the $1 million F-ups by getting AI to review and analyse what you're doing. Getting it to do the risk matrices, getting it to do all these kind of things. Anyway, there's my risk matrix. Right, well, I'm pretty much there. I've got one more example. Greg Brockman, it's being recorded, isn't it? He's interesting. He's very confident about AI. He's the chair of OpenAI. He said with Codex, so you can believe with Fable, with Claude Code, whatever, feels like whatever can be imagined can be created. He said this in February. I was like, yeah, a bit of hype. No, true now. Fable, ChatGPT 5.6. Anything whatever you can imagine, AI can now create with code. So I live in St Heliers, not far from here. Anyone here from AT? Good, brilliant, you'll love this. So I said, hey, so the example here is not what you should do, but what someone, any old person in St Heliers can do right now. They can go into Claude and say, hey, build me a traffic microsimulation of St Heliers Bay Road and St John's Road. The problem at the intersection of the congestion with the right turn, and the rest of it's boilerplate, so you could do that for anything. You can do this right now. You could put in whatever intersection. It was funny, it was begging me to do Royal Oak Roundabout. Like, how did the AI know? So here we go. So it took about an hour for it to do this. Here is the end result, and if you want to go to it, I've put it on my website, atupgrade.madensor.online. Now, I used to do Premix and AIMSUN and stuff, so I'm like, this is pretty good. I'm adding the scats routines onto there. It somehow knows what those are. It's a bit slow, so I'm going to put the simulation speed up to 7x. Honestly, this is how the world should be. Everything should be 7x. What else am I going to do? Oh, I might push up the traffic on Koei Road, because I can. Where's my mouse gone? Anyway, we're almost there. This is it. I've got one more slide after this. And here's all the delays. I'm only getting about 2,500 vehicles an hour through, which is rubbish. It's been like this since the 70s, but rubbish. So AT, they're like, hey, we've got a brilliant idea. Why don't we turn that through lane going up into a right turn lane? Good. Up, Matt, up, up, up. Yep, there it is. Apply AT upgrade. Remember the instructions I gave it? It actually went and it found what AT were suggesting, and so it added this in. Like, so here we go. Off we go. So I don't know, we used to charge tens of thousands, 20,000, 30,000 bucks for this kind of stuff. I put this on the Facebook group for St Heliers, and everyone's like, whoa. So what I'd say is don't cancel your Aimson license, but this is what, look, this is brilliant. This is what your average punter is able to do. And so we used to have a bit of a moat around what we did. You know, we'd kind of say to the public, oh, this is a good idea, and they had no way of testing it. Now, what did I write? Do me a micro-simulation of St Heliers Bay Road. That's all I need to know to now have like a really good model. So we have to be careful around that moat, but what keeps us there is discernment, professional judgment, and trust. So these are the examples I just went through, but this is my last slide. If I went through each of these points, I'll be here for another 10 minutes, so you'd be glad I won't. You might want to take a photo of this. This is what I say to people. These are the top, I think there's 8. Oh, thank goodness. These are the top 8 things to do right now. And the organisation, so my day job is working with organisations. I don't do anything more than a day because they can get started in a day. We are starting to see organisations becoming those pink salmon organisations. They're accelerating away. They're only about 6 weeks ahead of us, but that's now starting to happen. So thank you. That's my website. You want further information, but I hope your life's not quite the same as it was half an hour ago. I hope you're a bit more confident about AI, but also a bit more cynical about its capabilities and where it fits into what you do. So thank you.
Hold on there, Matt. Hold on. Hi, we've got an extra 5 minutes because there's been a fire alarm go off in the kitchen. So morning tea will be 5 minutes late. So this is an opportunity for a quick few questions for you from the Slido. I don't know if any of these questions have been generated by AI to put in the Slido, but I don't think so. How long do you think before discernment can be done by AI?
It's impossible. Believe me. It's just that when you dig down into how the AI works, it is one word after the other. And people are, they really wanted to give it the instinct so that it won't tell presidents to go to war. There should be something in AI that it just can't do that. It's impossible at the moment with the technology. So good news for humans, discernment is something uniquely human. We could have an argument, put Sam Altman there and he might have a different view. Don't believe the tech people because they see the world in a very different context to what civil engineers do, as it turns out.
Yeah. One last quick question. What's happening in the AutoCAD computer-aided design space?
Yeah. Well, there's lots happening, actually. How long do you have? There's a guy on YouTube called, I think it's Mark Ferry, so have a look. So what we're finding is that the best way is for AI to write code to manipulate digital models. And so that's kind of where things are at because it can write code to do things very quickly. And that's what Mark Ferry talks about. He has lots of lovely 20-minute videos. And
one last question. At what point does AI-written code become incomprehensible to humans in security?
Yeah, I'm the wrong person to ask, actually. All I'd say is, back in February, I've got lots of friends who are coders. We have interesting conversations. But they were saying, look, we're not scared of this at all back in February because it makes so many mistakes and it will screw it up and oh my goodness. They don't say that anymore. Now they're like, we're not quite sure how this works anymore, but we can't not do it because it's just so productive. So I love what Andy said because, you want to dig down in the individual code lines and work out how it's going to get hacked. Well, AI can do that. The job, I suppose, we have is to sort of stand back and make sure that the use cases that we have are safe.
Thank you. Thank you very much. I'd now like to welcome Lee McKenzie from Omeo. Thank you.
Kia ora koutou, katoa. It's really, really nice to see so many familiar faces today, but also fantastic to see a lot of new faces as well. So If this is your first T-Tech, welcome, and we hope we keep seeing you year in, year out. I actually do work for Omeo, but I'm not here speaking from Omeo. I'm actually speaking here for ITS New Zealand. So I'm just going to really quickly take you through the next events that are coming up in the ITS world. Thank you for putting me after Matt, whoever did that. That's a really tough gig, so thank you. But on the other hand, was that not an awesome presentation? So awesome, and we've seen many, many good presentations. So if you want to see more, this is what's coming up. ITS Australia Global Summit in September this year. If you haven't been to one, try and get to this. Their events are always fantastic. Great program, great technical tours, great social events, and it's in Melbourne, what's not to like. So look at that, please look at that and look at going. ITS World Congress in Gwangyang in South Korea. That's going to be an amazing event. Some of us were there earlier this year looking at and helping with the program and looking at the facilities. It's going to be absolutely fantastic. I do have a little video to play for the World Congress. Where's my, there he is, man up there.
You see, mobility isn't just about getting from A to B. Nor is it about simply going faster or going further. Because the essence of mobility is in opening up new possibilities for a truly different future, for a truly better life. So here begins a new chapter of mobility, redefining what's possible to redesign each and every journey. Every moment, a new discovery of a whole new freedom of movement. With innovative technologies surfing every domain of our society. So we can reach the unreachable and keep our loved ones safe. It's about barrier-free mobility for everyone. So anyone can move freely, anytime they want. All of us connected, closer than ever before. It's about a freedom to go wherever and whenever your heart desires. For journeys beyond your wildest imagination. To explore those endless opportunities and possibilities in this whole new world of mobility. So come, imagine, and experience the future of transport systems through technology for humanity of infinite possibilities. Beyond mobility, connected world. Right here and right now at ITS World Congress, Gangneung, Korea.
If you haven't been to a World Congress, go. It's like these events on steroids. It's the only way I can explain it. It's the most amazing thing to attend. You will hear about the latest products, developments, great research. It's just absolutely incredible. So I recommend if you can get there, go. The ITS Asia Pacific Forum will be held in Singapore in 2028. And then the next ITS World Congress in this region will be in Taipei in 2029. But in case you think I've forgotten, I've saved the best until last, the ITS Asia Pacific Forum. Honestly, we are so excited about being able to host the forum here in Auckland. We're open for submissions already. If you're thinking about putting in a paper, don't think about it, please put in a paper. We want as many people to make submissions as possible. If you want to promote your product, please have a look at the exhibition space. We've got exhibitors coming from all over Asia Pacific, so they will sell out, the booths will sell out, there's no doubt about that. please think about sponsorship. There's some amazing sponsorship packages. And so in relation to both the exhibition space and sponsorship, please talk to Kim, who you've seen, she's waved from the back, or Britt, about both exhibiting or sponsorship. And finally, if you've got any ideas for technical tours, please come and find us and talk to us about technical tours, or in particular, find Scott Hammond. Is he in here today? May not be. Scott Hammond is organising the technical tours for the forum, so please find Scott, and of course all of this information is available on the ITS New Zealand website. And finally, we need you to help us promote the AP Forum. If you don't have one of these little badges, we've still got some here, come and find myself or Kim. Please talk to your colleagues about the forum, talk to your customers, talk to your business partners, and honestly, you are probably our best advertisement for the AP Forum, so please help promote the forum. That's it from me. Okay. That's it. Thank you.
Thank you very much. We've still got just a couple of minutes to let the catering team get back together, so I'm going to have a look. Oh, it's all disappeared from the Slido app. So I'm actually going to do something radical and ask if there is a question live from the audience for any of the speakers that have been here this morning. Do we have a microphone around? Is there anyone who's got a speaker that they want to ask, a question that they want to ask? I've got one actually. Program, and there'll be a microphone coming down for you. With your certification program, how does that work financially in the business kind of case behind that? Do people pay to become certified? Who pays for their data? Are they paid? Do they have to pay to give it? How does that work? Down at the front here.
How are we going? 1, 2, 3? Yep. It's a really good question, Liz. Technology providers pay to become certified. They're incentivised to become certified because of the policies that governments institute. So they see markets being created through government policies that are introduced. So that's the first part of the answer to your question. Second part around data. Data is exchanged with TCA from individuals' vehicles in return for some regulatory incentive. So there's something in it, not necessarily financial, but if I'm a road user, I'm getting some benefit. And usually that's a regulatory benefit. It might be, I don't need to apply for road use charging permits. I might get some subsidy through registration. I might get improved travel benefits or what have you. And this is the art form that makes the framework stand out globally, is because it requires policymakers to get creative and to think outside the box. And I dare say it might be a role for AI to come up with some new incentivised models, because that's the X factor that drives the framework.
Yeah. And to follow on with it, there's a question, do you receive and aggregate that telematics data in real time that could be used for real-time systems?
We're moving to real time, and that's based on what people expect of us. We're getting feeds from technology providers in near real time these days, just because it's easier. In terms of our aggregation and so forth, that's running at about a 24 to 48 hour cycle, but a process that can be sped up over time based on need.
Thank you. Any other questions from the audience for anyone? No? Okay, well, we'll wrap up there, and you can walk slowly up. Slowly up to morning tea, and hopefully it'll be ready by the time we get there. Thank you.